Good evening, all. I'm Nimisha, and it's a great pleasure for me to introduce today's speaker, Srijit Ghatak, who will be presenting on the topic How to Transition into Data Analytics Field. This session will help you understand on what is data analytics, what are the various roles to expect in the industry, tools and technologies required. Also, this session will help you know on what is the right approach to learn and prepare for interviews and make CVs, which will further help you to get a head start in accomplishing a successful career in data analytics field. So before we begin the session, I'd like to introduce our speaker, Srijit. He is a certified data science professional from Great Learning with in computer science and engineering. He previously worked at Accenture and now he is working at Cognizant as a data scientist. Finally, I'd like to suggest all our viewers to post your queries in the chat section, and towards the end of the session, handpicked relevant queries will be answered. So stay tuned and over to you, Srijit.
Hi, good evening, all. Today we will embark on a journey to understand what are the different fields of analytics are there in the market, what all different kinds of roles and expectations are set from a professional in deriving the business values, what all we need to know, what are the skills we should possess in delivering these insights to our clients. Broadly speaking, there are three different analytical fields. They are the data engineering, the data science, and the business analyst. So first we'll start like what data engineer is, what are the different roles, what skills a data engineer should have to derive the insights. Plus, after that, we will also try to see what and how exactly the role of a business analyst fits into the paradigm of both data engineering and data science, how it connects the both. And finally, the future technology, the role of a data scientist, how do we make use of predictive models and various future forecasting requirements which help an organization grow in various different aspects. But all these things finally tend to give us the one important aspect, that is to derive business value, which in turn helps us in giving the business dollar profit for an organization. All of these involve in processing the raw data and then transitioning that data into some kind of insights which our client or the organization can leverage to enhance their performance or to make good informed decisions for their future journey. So finally, we will try to understand how we can use all these three things and carve our path towards being a data scientist. So before that, I'll give a brief intro about what my career path track is, how I have uh, come into this line, or what are the tools and technologies which inclined me in coming towards this direction and all. So in 2014, I actually completed my engineering in computer science from VTU Bangalore only. And after some time, few months, I joined Accenture in the same year. When I joined Accenture, first, although being from a programming background, I did not go directly into any kind of programming at all. I was put into an ETL tool called data stage. ETL is something we will see further down in the slides what it actually does. So with that, I was also put into a training for reporting tool as well known as Cognos. I started my career with that. Did not work too much on those two technologies, maybe around 4 5 months. Then I moved into another a kind of ETL tool known as Informatica. From there, my journey to data warehousing started. And in 2016, I was working for developing various data warehouse models and data marts, doing the data engineering aspects to accomplish those data warehousing models. So I was dealing with tools like Informatica, then Unix and SQL. So these all things comprises of the various aspects that are needed to become a data engineer for developing the various data warehouses. So while I was working in this data warehousing domain, I was working for a telecom industry. In that telecom industry, there was a use case of customer churn, which was the turning point for me in understanding what predictive model can actually do and how I should proceed towards this direction. So what is churn modeling? Churn modeling here meant that a company is trying to figure out in advance which customers might leave them. So I started digging up more into this domain. And then I came to the understanding of various machine learning algorithms which are possible in making this happen. So at that time, I came to know about a great learning PGP course as well. And from there, in 2017, I started my journey in machine learning. While I was pursuing the certification from Great Lakes, that same time, I started to understand or dig deep into the roles of what a business analyst should do, what knowledge a business analyst should possess. Why this is important? Because a business analyst is always close to both the data engineer and the data scientist. It has to coordinate both the things. So I figured out if I want to go into a machine learning domain, I should have a fair good understanding of what a business analyst should know. So then I started knowing the various charts, graphs, how a client interaction should be, what are the business models, or how a KPI should be derived and all. From there, once I completed my course from Great Learning in 2018, I made a transition as a data scientist in Cognizant. And in Cognizant for about 1 year, I completely worked developing predictive models in machine learning for various domains like retail, healthcare. And while I was doing this, I could also see the trend of the current companies going towards the cloud aspect. So now people are trying to go from on-premise legacy tools and technologies to cloud. But in cloud also, they do the same things. They do the data warehousing now these days in cloud, and they do the data science also in cloud. So in cloud, basically, it is a combination of both big data, data engineering, and data science. So presently, I'm doing uh, the data science work on cloud platforms and trying to grow my knowledge in more depth in this aspect. So this is about me. Now let us go into our first analytics platform, and we will try to understand what it does and how it does. So our first platform is our data engineers. So data engineers are those who actually help in developing customized business specific data marts or warehouses. So what does it mean? It actually, data engineers actually help in creating centralized repositories of a lot of uh, various specific domain related data from which further analytics and BI reporting can be done. They help in basically integration of different sources for ease of use and exact reporting. Not only this, but a data engineer also help us in what you call platform upgradation. What is a platform upgradation? There can be a few aspects of this. For example, suppose as an ETL tool, we are using Informatica 9.5 version, but now the company needs to upgrade to the latest one, 10. So upgrading the version of Informatica from 9.5 to 10 is a platform upgradation. At the same time, suppose a database is located in Oracle or Exadata, and we need to move it to Teradata. So that is also known something as platform migration. Then one of the major roles which all the data engineers play these days is the data migration. So what exactly a data migration is? See, let's take an example, the legacy systems of telecom domain. A telecom domain have lot of information for their customers, like their address, their monthly billing, their monthly internet usage, call usage, etc. And previously, when all this digitization did not happen and all, at that time, all these data were stored in the legacy formats, which might be the an CSV file or an Excel format or in text. So, with all these things on a separate platform, we actually cannot do any real analytics on them. We need to derive a relationship among them to do further analysis on them. So, how do we achieve that? To achieve that, the demand came to make them centralized in some new platform. It might be we are moving all this legacy data to a centralized warehouse in Oracle or Teradata. So this is how the complete data migration activity takes place. So primarily, there may be three use cases for a data engineer. First, data warehouse creation, which can be done in varieties of ways, like top-down approach is there, bottom-up approach is there. They play the role of data migration and platform migration. And these all are done using few models. What are these models? These are the entity relationship, facts and dimensions, and data vaults, the major models that are being used. What is an entity relationship model? So it is something like a parent-child relationship. Every customer's billing invoice is always related to where they are staying. So the address here is the master and rest are the child. So it forms a parent-child kind of a relationship. Then there is something called facts and dimensions. What are facts and dimensions? Facts are something which have the business keys, and dimensions are something which describes it or gives the attributes for those keys. So it generally forms a primary key foreign key relationship between the tables that it has. And it can be modeled in various different ways. There can be a star schema, there can be a snowflake schema, or it can be a hybrid of both the things. And the third one is a data vault model. What is a data vault model? It primarily consists of three things. First, it has a hub. Hub is nothing but it is similar to what are facts. It consists of the business keys. Then it has something known as satellites. What is satellite? Satellites are nothing but the dimension. So it also describes and gives the attributes for the hubs. And link is something which actually connects this hubs and satellites. So altogether, this is this comprises the data vault. It is not necessarily used, but convention is that data vault type of modeling is quite preferable for any platform migration. For data migration, facts and dimensions or entity relationships are most commonly used. And to now know what all things are actually required to know in the aspect of skills for a data engineer, maybe they need to know at least some ETL tool. ETL is what? Extract, transform, and load. We extract the data from a legacy, we transform it according to our business need, and we load it into a centralized repository, suppose Teradata, and from there we do the visualization. So an example of ETL tool might be Informatica Power Center or Talent. Then they need to possess a good heavy amount of knowledge in SQL as well, because a lot of the data fetching and data validation extraction happens through SQL queries. So they need to know, they can know anything, but Oracle and MySQL are the ones which is most preferably used. So a knowledge on SQL will be very good. And finally, they should know something on Unix. Why Unix? A lot of file manipulation or scripting for automation or job scheduling, like doing cron job scheduling, happens in Unix. So a combination of these three things is the main aspect for a data engineer to know. Then what are their major roles or responsibilities? First is data acquisition. What is data acquisition? Is try to get the data from the legacy sources as per the design or the architecture in that format. Second, develop, construct, and maintain architectures. What does this mean? To do the migration or to create a data warehouse, we need to have an architecture design. Based on that architecture, what we have to do, build our pipelines, which will move the data from our source to the target and do various testing and validation to maintain all these things. Once this is done, to maintain the framework that we have built, we need to have regular checks on it, we need to maintain it. Then we should able to fine tune our framework or pipelines or the queries in such a way that it delivers good performance and quality. So this in whole is the requirement for a data engineer, what a data engineer primarily do, the things needed for a data engineer professional. Okay. So now we will go to the second analytical field, which is in very much demand, is the business analyst. So what is a business analyst? Business analysts are those who help to develop custom intelligent dashboards. Basically, they are the people who will help us in creating valuable insights in graphical forms for the various intelligent dashboards and BI tools we have. And they tend to develop these insights in such a way that we get lot of granular details. For example, first, if we are seeing a data or trying to understand something for a specific country, then it should get drilled down to from country to state, state to city, city to district, like that. So granularity should be there. And how it helps us? It helps us in two aspects. First, it can give us the pain points of why a certain region is not performing good in a particular sales, or why a certain region is performing very good. So if we can come to some insights based on our visualization, then we can implement the good things of a certain place to the poor ones which are not performing well, thus trying to increase the business value and trying to understand exactly how it can help my organization or the client. So for a business analyst, the first task is developing a BRD. What is a BRD? BRD is a business requirement document. They have to deal a lot of the times with the client, understand what their requirement is, then make it into a document, which then gets processed to finally come into picture of design document. So the design should consist of various KPIs. What are the KPIs? They are the key performance indicators which will help the company or the organization to understand the pain points or the good aspects of a particular sector which they are targeting for. In addition to that, it should have proper metrics to complement the KPIs, and a business analyst at the same time should have a good knowledge of ML as well. And it needs coordination with data engineers and data scientists. Why? See, uh, in our BI dashboard, suppose we want something to show for a forecast. Suppose let us take an example of the sales forecast. So to do the forecast of sales, it will be done by a data science team, but the data to that team will be obtained from the warehouse which has the sales data created by the data engineers. So a business analyst will coordinate with both the data engineers and the data science to get the appropriate data and the forecasting done, which will then get shown in the dashboard as per the needs of the client. So for a business analyst, domain knowledge is very important. Why? See, based on the understanding of the domain or the experience that a person has in their domain, he or she can easily formulate a BRD. They can arrive to a conclusion of what KPIs to be used, which is the main aspect. Like in finance or healthcare domain, they a lot of the people uses rolling average or moving average. They take the annual operating plan and find some metrics or KPIs on that, because they are the important things on which the whole markets work, or on that the whole sales work for them. So a good domain knowledge can help you in finding the calculation logic for the KPIs to be used. Then, since it is all related to visualization, how visually we can represent the data to our clients in layman terms so that they can take good informed business decision, visualization knowledge is pretty much required. So few of the visualization tools which are being heavily used in the market these days are Tableau and Power BI. They can be easily integrated with various data warehouses. They have multiple source compatibility with them. A lot of smart intelligent analytics is there. uh, Various kinds of charts are available. So these two are the prime players in the market now. And the last very important thing is the inference. Inference here meaning from the ML models, the output that I am getting, how does it help my customer? How it is helping to achieve the target, or how it is improving my business? That understanding is very much required. And with that understanding, how to depict it visually using charts or various different methods, that is of prime importance, because that is what our end customers or the exec team will see to make their decisions. And to do all these things, proper designing is required. Designing in the sense how the flow of a dashboard should be, or how my uh, storyboard should look like, because it cannot be abrupt. It has to flow in a smooth fashion. Finally, we will see what are the different responsibilities that a business analyst should play. First, it has to do a lot of client interaction to get the understanding or knowledge what the client's expectations are, and accordingly document them for the design and analysis of the same. So after this documentation and designing has been done, the formulation of the KPIs based on the various aspects taken into consideration has to be developed, and their calculation logics has to be formulated. So once that is done, we need to create or design the proper storyboard or dashboard which are in sync, giving the proper flow of information that is needed, and we can get that from various dashboards or executive summary boards. Both convey more or less the same thing. Executive summary boards are a little bit aggregated information, whereas the dashboards tend to give you more granular level of details. So this is how the role of a business analyst come into picture and how it fits with various uh, ML concepts and the coordination between both data engineers and data scientists. Now we will move to our third analytics platform, which is being known as the next big thing or data science field. So what exactly a data scientist do? Uh, how does it help an organization? Why it is so much in demand, and why it is being told that it is the future of the technologies? So data scientists are those who actually help in giving valuable insights or help an organization deliver add-ons to their business. How do they do that? By finding trends and patterns. See, what will happen if we find trends and patterns? We will be able to forecast or predict the future behavior. Once we do that, we can beforehand make optimal and informed decisions through various inferences and prescriptions that we have. So let us try to understand what are the various important steps that a data scientist should know. A data scientist should know, before doing any model, it has to know the descriptive aspects of that data that they have in hand. What do we mean by that? Descriptive aspect means the summary statistics of the data, like the central tendencies, the mean, median, mode, their range, if we have uh, the data normally distributed or not, if they are skewed or not, or what we can say, if there are any outliers or clusters which we cannot see distinctively. Those all things first we need to do through various visualization and statistical approaches. Once that descriptive knowledge we have, from there we need to go to the diagnostic part. What is diagnostic part? What do we do with the information that we got from our descriptive approach? We create hypotheses. We try to make, is this variable from the data set important or it is not that important? We make few such assumptions and proceed ahead for developing our model. So the development of the model is the predictive part. What do we do in predictive? This is the part where the different algorithms that we need to learn to do our forecasting or future prediction. It has lot of ML concepts which can be supervised or unsupervised. We'll see in a bit what these two are. But once we get the predictive power, or we develop a model which can predict the future, with that, we need to suggest the client or our end customer that what they need to do. Like in the churn model, if we come to know that this person is going to leave my company after 2 months, then how do we stop it? So to make that plan, it is the prescriptive part. Suppose we tell you the company that they need to give an offer for that. particular person. So that is the prescription part. So in totality, these are the four things that a data scientist should be very thorough, should be very good at in developing the further models. And this model developments, that is also of like, generally they are categorized into machine learning, deep learning, and artificial intelligence. More or less all of them try to achieve some or the same thing, but machine learning are the conventional methods of prediction. Deep learning is something known as, like, if we are trying to do facial recognition or classify an image, those things come into the deep learning aspect. And artificial intelligence, creating AI chatbots and all, those things will come under artificial intelligence. But doing a classification or regression, like what will be the sales for my next month and all, those things will come under normal machine learning things. So let us try to understand uh, what are the different skills required and what role they will play in understanding uh, the data science aspect in greater detail. See, in subject wise, a person should know a little bit of statistics. Statistics is required to do the test, to validate our hypotheses. That is the prime aspect of knowing statistics. And it also complements the descriptive analytics part, as it will help us in visualizing the trends and discover the central tendencies. Programming is needed because we need to do the coding for our ML algorithms in one of the various available programming languages. The two main programming languages that are being used are R and Python, and little bit of knowledge in linear algebra, the mathematics part. So basically, if we see this, we can tell that a data scientist is a person whose programming is better than a statistician and whose statistic is better than a programmer. So these are the subject knowledge that a data science professional should try to gather. And coming to tools, since it is using R and Python, so Jupyter and RStudio are the most preferred IDEs that people use while developing the code. And uh, visualization tool also comes into picture. Why? Because just developing or predicting the output is not going to suffice until and unless we can present it in a very nice format to our users to understand. So a visualization tool like Tableau can help us in greater detail for all these things. And then coming to the knowledge of the models, broadly classifying them as supervised and unsupervised. Supervised are something for which we know what our end target is. What do we want to achieve? Like, we need to classify if it is 1 or 0, or we need to predict the sales. Then it becomes regression. So when we know what our end goal is, then it becomes a supervised kind of learning models. And the various models might be regression, logistic, random forest, decision trees, boosting, etc. Unsupervised are those models in which, when we start, we actually don't know what our end goal is. We are just trying to find out the various different patterns or trends that we can see in the data set, and we do clustering of those. And once the clusters are formed, then we try to come up with some target and do supervised modeling on them. Like, uh, we make clusters using k-means or hierarchical clustering. These are the various things that data scientist or a machine learning engineer should know in terms of model building. And obviously, the requirement of languages are Python and SQL. Why SQL again? Because here also lot of the times uh, data extraction needs to be done from databases, which will heavily require SQL. So knowledge of these three or understanding of these three will help being a data scientist very easily. See, and now lastly, we will have a look at what are the different responsibilities a data scientist has. So the first important thing is data discovery. Means that they need to have data to go ahead to build the model, correct? So how do we get that data? So data discovery aims that phase of the project where we try to get the data from various sources. It might be a survey data, it might be a business data, various, but we need to have that and create a centralized repository or a data set from that. Second, we need to do lot of data cleaning. Data cleaning is one of the biggest time taking aspect of any model building. Majority of the time for a data scientist will go in cleaning the data, because there will be a lot of anomalies. Suppose uh, if we don't have data for 100 rows out of 1000, then what do we do with those 100 rows? The approach might be different. If we don't have the data for 100 rows in 1 lakh rows, then what do we do? The approach will be different. How do we substitute it? What approach should be taken? Various consideration in coordination with business needs has to be taken into picture to do the data cleaning. Once the data cleaning is done, we need to derive some descriptive and diagnostic hypotheses to do some inferencing from that. Once we did that, we need to build a model. Once the model is also built, we get our final target output. Then according to that, we need to prescribe our clients to do some kind of uh, decision, to make some kind of decision which might help in their business or dollar value profit increase. So data science actually consists of lot of things. So an in-depth understanding will take some time, and the best advice that can be given to anybody aspiring for that, once they all start to learn all these things, it is very much advisable for them to go and practice the online data sets that are available and try to understand why which statistical tests are being used, which models are being used, what are the various parameters a models uses, and why to use them. So this is the field of data science. And coming to the end, so finally, let me talk about how should we prepare for an interview, or how do we showcase ourselves from the data analyst perspective. So our profile should be very good. Second, our knowledge should be in par with that. A data analytics profile should be very crisp, condensed, and clean. There should not be any junk information. Only the relevant things should be there. That also with proper categorization should be there. If I don't categorize the things, then it does not give a recruiter the proper information that they want. The categorization can be like, first the objective, second what are the different analytical approaches or models used, then what was my performance parameters that I took into consideration, finally the what is the business outcome. And then the order should be proper, like first I start with the summary, then I give my skill set, then work experience comes, then education, uh, our academic projects comes, then finally the achievements. The proper ordering has to be there. Detailing of anywhere with any work in analytical logic should be put, be it ETL, visualization, anything. For visualization, I can give the KPI calculations. For ETL, I can give few of the very important transformation logics that I have used. If I'm making any predictive model, then the model interpretation has to be there. Always, what performance consideration we have taken, we should mention that, because based on the performance only our business outcome is delivered. So we need to correlate those two for sure. And again, the KPI interpretations means how our business outcome was achieved using the KPIs that we formulated. So this should be the flow of a CV that a candidate for aspiring to become a data scientist or going into data analytics field should have. And finally, the knowledge. I'll concentrate mainly on towards the data science professional aspect. The individual should have good knowledge on the various statistical tests that they need to perform. The few common ones are the like chi-square test and all. So they should know, or the t-test, why do we do that, when do we need it, because they are the most common and heavily used ones. Then some basic programming. See, the ML model programs always remain same, but there will be times when some models or or library has to be developed on our own. So that much programming knowledge we should have. So we should keep practicing some basic programming skills. Then the ML concepts, for sure it is needed, like why and which model to be used and how to be used, and what are the different parameters we should use them, and how can we achieve greater detail on these concepts by using hands-on practice. Then there are always SQL scenarios, because we need to know the various ways through which we can extract the data to make a data set from various databases. So that's why SQL knowledge is important and we should practice on that. And finally, to get a logical understanding of the analytical potential a candidate has, there is something known as guess estimates. A candidate should obviously prepare for a lot of the guess estimate kind of question, because it will help them increase their analytical or logical thinking power, which in turn will help in showcasing the analytical aptitude towards a problem. So all in all, this is how a profile or a knowledge check should be done, and these are the various fields of analytics that are heavily being used in the market, and data science being the foreground player these days. These are the profile and knowledge checks that we should have. I believe that's all from my end. We will now go to the Q&A.
All right. Thank you, Srijit. That was a wonderful session. So I'll just read out some of the questions that our viewers have posted. So, yeah, first question is from Priyadarshi. She has asked, how can analytics help to grow business for clients?
Okay, so see, uh, there are a lot of historical and raw data all the organizations are having. What do we do with that? Generally, in the past days, we never did any useful things with them. These days, because of all these data science approaches and all, we can take the historical data, try to train them, find patterns or trends in them, and get a predictive model built. Like suppose if I have sales data of past 5 years, we can get the we can predict the sales for the future year, and based on that we can plan our campaigns or offers. Because if we can plan ahead, it obviously helps us in cost optimization for a company. So finally it is adding some value to our organization.
Okay. Next question is from Raghav Arora. How to move into data science or analytics field after 1 year from civil engineering?
See, uh, it can be any field. The main aspect is all the fields have data. Okay, so whatever data you have, with that a case study can be formulated. With the increase in the knowledge that you are trying to achieve in this field, parallelly you can also work on making some use cases or POCs for the work that you do, the data that you have with your organization. Once you do some case studies or try to build up some POCs with the knowledge that you are trying to attain in this field, both can be collaborated together to move into the data science field. And a professional with less experience, like below 2 years and all, it is relatively easier for them to transition into this field of analytics.
All right. So, Rima Tyagi has asked, if we have data, which tool is best for analysis?
See, it again depends on what your business wants to use. To speak frankly, uh, it is the business decision what tool they want to use. They can tell that you build my predictive model using R. They can ask you to do it on Python. They can even ask you to do using Azure ML Studio, Amazon SageMaker, because there are a lot of now automated tools also which can help us in achieving the data science aspect or the predictive model power. So the main takeaway should be the understanding of the concepts so that you can implement and infer the required knowledge from any given tool.
All right. So, Rajit has asked, does the domain knowledge help in the data discovery?
Obviously, it plays a very major part. To give an example, when we actually try to solve a use case, to come to an understanding what all data we need, generally every team will have a domain expert or an SME with them who helps us in doing the data discovery. Based on his understanding and the data availability, we make collaborated data set, and with that we proceed further. But obviously if somebody has a domain knowledge and then doing data discovery for that particular domain is will be much more easy than not having the domain knowledge.
All right. So, Sumit Shah wants to know, he has said that we are seeing artificial intelligence is playing an important role in every field. What do you think is its role in business analyst? Just like there are courses like AI project management and agile business analyst. So he wants to know how important AI is in business analyst field.
See, um, I won't tell that AI knowledge is very important for business analyst. For a business analyst, how the inference from the AI is being used, that is more important. Because for a business analyst, the main task is to convey the important message in a visual aspect to the end customer so that they can take informed decision. So it is always not necessary to know in depth the inner workings what an AI will do. If you can understand, okay, if I will get a categorical output, so based on that you can derive your KPIs. So, in all, or to keep it short, a fair bit of understanding of the concepts will suffice, and not an inner deep dive of an AI knowledge is required specifically for BI roles.
All right. So Abhishek Nagarajan wants to know, I have enrolled for MTech in data science and I would like to know what are the prerequisites for approaching this domain.
Okay, so as discussed earlier, so if you are trying to pursue an MTech in this field, it will be good or it will give you a head start if you can read something on the various simple ML algorithms like the logistics or the regression things with some statistical uh, tests that we use. You can Google it, you will find the easy tests that we do. If you have a fair grip of some of the statistical terms that we use and the basic inferences we try to take out from the simple algorithms, I think that should be more than enough to get you started in this journey. And then as you progress in this, you can keep enhancing your knowledge and go to the complex part.
All right. So our viewer Vineet has asked, what are your recommendations on using some of these data science concepts and practices into system engineering, say analyzing and predicting performance behavior of a storage cluster? So he wants to know how it will be helpful for a system engineering.
Okay, see, let's take the example of migration. Okay,
There is a slight internet network connection problem.
hello, am I audible?
Yes, 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 Srijit.
Yes,
You
I
can
think
continue.
some, yeah. So, as I was speaking, so with every batch, since the migration increases, so if we can get a predictive power to know how much time the next batch of migration will take, so it can help us in understanding the number of customers to migrate, which might reduce the chances of error. That in turn will give a smooth and cost effective measure of migration. And similarly, we can take use of that to make a capacitive power for migration of particular systems, that how much computation power we need for a particular set of migrants.
All right. So Akshay Pawar has asked, sir, what advice can you give to become a data scientist for a second year BE student of a CSC field? and what are the skills he should focus on in college life?
Okay. See, since you are in a college and you are studying in this field, it should be quite easy for you, because from this time only you can start preparing to come into this field. The tools and techniques that I was talking about, you can start to have a grip on them from now only. Like, you can start practicing the SQL to understand how the data fetching will happen. You can start concentrating on programming to know the eh, logics of how a library or a module can be written. Similarly, you can start reading about, as you grow in your field, you can start reading on the various different algorithms or approaches that are being used in this field, and accordingly you can try to make your path towards this field. With the additional time that you have, that will be the biggest plus point for you.
All right. So Utsav Sharma wants to know, I have 6 years of experience in mechanical design engineering and I wish to switch to analytics. I have been learning Python for more than 3 months. I would like to know how this can help me choose in that field in data analytics.
Okay. See, for any senior professional who is not exactly related to this domain, for them, the advice that I always give is, first try to get whatever data that you have in your organization or the work that you do, because there has to be some kind of data. On that data, try to come up with the case study. It's not necessary that you have to do a predictive model on that, but try to come up with a case study, have the understanding or the logical inference on how the things can be moved further, how you can get business benefits out of it. Once you start doing this case study, you try, then move on to developing some POCs, internal POCs, which you can do based on the knowledges like you are trying to gather. You can try to switch your domain within your organization first, or try to come to a business analyst role, because business analysts, they don't need a heavy hardcore developer role or hands-on coding knowledge to be in this field. They need to understand the concepts well. Once you have done this, then you can finally slowly transition into the field of data analytics, which will be the correct path for anyone in such situation.
All right. So, Srijit, I want to know how was your overall experience in Great Learning and how was your journey throughout as a data scientist?
Okay, so it all began when I started to get inclined towards the predictive analytics knowledge that I wanted to gain. And while researching, I came to know about Great Lakes and Great Learning. So the best takeaways for me would be like the platform that Great Learning creates, because they have amazing faculties, very knowledgeable. So the depth of knowledge you gain from this course is exactly like a professional working in this field for 1 or 2 years. And the most important aspect is what Great Learning does. They do the things practically rather than research oriented. Because when you go to an industry, everybody tells that you need to deliver the project, you need to complete this. So for that, research oriented knowledge is little bit less required, rather practical hands-on approach is needed. And Great Learning does these things fantastically. So that was the best takeaway, which has helped me to transition into this field as I wanted to. And now I am trying to grow myself more into this field, and I'll be always happy to be connected with Great Learning.
All right. So, I would like to know how important resumes are for a learner and how it can affect in, applying for jobs. Could you give us some wisdom regarding that?
Yes, see, to be practical, recruiters does not spend too much time on a resume because they will have lots of resume for one single position. So a resume should stand out. It should deliver exactly what we need in a very condensed manner. So categorizing the things in a proper way and depicting only the analytical part, because we are trying to move into data analytics, correct? That will be the major important thing. And mentioning proper skill set at the top, which helps with the word search, because different organizations will have requirement for different projects. It might be for classification kind of thing they are looking for. They might be looking extensively who has experience in regression or unsupervised learning. So those things need to be mentioned very clear in a crisp, condensed manner. The CV should not be lengthy. It should be very, it should be made in a very smart way.
All right. And finally, what do you suggest the learners, especially if we are looking for transition into data science field? What is your suggestion that you would like to give?
See, there will be two categories. First will be for the freshers or people who are having less experience. For them, it will be relatively easy to transition into data analytics. So, if they are the ones who are targeting knowledge on these three things plus uh, gaining some practical hands-on experience with the open data sets available in the market, that will really help them. And for senior folks, the suggestion will be like, first they should try, after gaining the knowledge in this field, they should try to first switch into their own organization, try to do some POCs or understandings in their own domain, then finally switch into the hardcore data science role. Or they can build a bridge using business analyst. They can go to a business analyst role, then they can shift to a data science role.
All right. So it's already time to wind up the session. I'd like to thank Srijat for all this wonderful session. I'm sure all the viewers have found this session insightful and encouraging. And also, I thank all the viewers who have posted relevant questions, and I hope we have answered it all. Thank you again, Srijit. Thank you for all your time. Thank you.
Yeah, thank you. Thank you, everyone.